This is very easiest part about force, right? Force. We cannot see forces, and forces are measured by newtons, respective to the Albert Einstein. No, Isaac Newton. And forces. It is respect to the Isaac Newton. Unit is Newton, capital N. We use many forces. Now, let's see. Forces are two types: contact forces and non-contact forces. Contact forces means there is need to be contact two objects. The force is formed by contact some object, like friction, right? If some two object does not in touching in contact, it cannot form the friction, right? And contact forces include friction like air resistance, water resistance, upthrust force. These are the contact forces, right? If object does not contact, the force does not form. And another one is non-contact force, like gravity, static, elastic, and magnetic forces. Those are non-contact force. They don't need to touch. Think about, if this is ground, this is apple, right? The apple does not touch the ground, but there is a force. That is what? Uh, that is gravity force. And if there is a ground and there is the object, when you pull, there is created the friction, right? So to form the friction, the two surfaces needs to be touched. That's why it is contact force. Now you know what is contact force and the non-contact force. And magnetic force do not need to be contact, so that is non-contact force. Forces can be big or small, so you can write 1.1 newton, 0.1 newton, 100 newton, right? Right. A force is denoted by using an arrow, because force is a vector. It needs to be mentioned the size and the direction, 10 newton. If you does not mention the size of the force, the size is denoted by the size of the arrow, right? Now it is some difficult method, because you need to measure the length of the arrow. So generally we use it with the number, right? Okay, this is 5 newton force, this is 7 newton force, 70 newton force. In this side there is 25 newton force, right? That is the point. It is measuring from the newton. There's a unit, and there is a direction. That the direction is must, and you need to use an arrow and show the head in which side or which side. You can see the arrow is long, the arrow is short. So there in here there is a large number of force, in here there is a less number of force. And weight and the mass. What is the difference of weight and the mass? Mass is how many amount that contains in some object, and weight is the force that happens because of the gravity. And weight is depend on the planet. Now think about, if you have 60 kilogram object. Think about, this person is 60 kilogram, right? If he is in earth, his mass is 60 kilogram. If he is in the moon, that is 60 kilogram. To think about the unit kilogram, because it's mass. And when you consider about the weight, you know weight is calculated by mass times 10. So it is 600 newton. But you know mass is in the moon, the weight is what? 1/6, no? So it is 100 newtons. Now you can see the mass does not change by the planet, but the weight is depends on the planet, because it happens on the gravity, right? And the moon has a less gravity than the earth. So mass unit is gram, kilogram or ton. There may be, but weight is measured by the Newton, because weight is a force. You can see these things, and there is something, there is upthrust force, right? You have learned it in the further analysis, and this is gravity. The thing is that you need to observe all are measured by the size of the arrow, right? You can see upthrust force becomes equal to the gravity. This one and this one is almost equal, right? So that is one. And let's talk about how to balance and unbalance force furthermore, and those are the things, right? Here you can see if it is mass of 210 kilogram, the weight is this one. I guess this is in the earth, on the earth. But in the moon, what happened? This is the mass is mass, but the weight has been changed, right? Can you see there is 2100 newtons, so the arrow is long, but it's 344, the arrow is short, right? Those are the things that you need to observe in these pictures. And springs. Materials and objects can be stretched or compressed. Stretch means if it is this object, after stretch it is becomes like this. That is the extension, right? Now second object, if it is this object, you can compress this one and it becomes shorter. Extension is this. And here, that is the point. And springs are made from coils of wires, and you know the examples for the objects. And if some object can compress or stretch, we call it as elastic object. And this is the original length x, this is the stretched length, and this is the extension. And there is a law named Hooke's. Hooke says as what? Extension is proportional to the force. If you make high force, the extension is increased. If you make a small force, the extension is low. And there is some limit of proportionality. Proportional means if you multiply by, if you increase, if you now think about, if it is here in the 5 Newton, the extension is 10 centimeter. If you double the force, the extension becomes double, it becomes 20. Again you double this one, it becomes double. That is what? That is proportionality. There is a limit of proportionality. After that, what happened? Now think about, if you stretch a spring more than the proportional limit, then what happened? It will not return to the original shape. Now think about, this is a spring, you stretch to here and you release it, then it came back to the original size. Now then what happened? When after you stretch this or more than the limit of proportion, then the spring will never come to the original shape. There is some gap. That is the idea of the limit of proportionality, this point. And you know what is Hooke's law? Hooke's law says that the extension is proportional to the force. That is Hooke's law. And this is the elastic limit. After the elastic limit is exceeded, the object will not come back to the original shape. The spring will then no longer return to its original length. There is always additional length. And the plastic items cannot be stretched or compressed, right? They will drop. Only you can do elastic objects. And you can use a force meter to measure force, and you know how to do that. The force meter is a pre-weight for measurements, and after that you can check the weights. And the friction is the one it formed by touching two objects. If two objects does not touch, the friction never formed. And there is a thing, the friction is always opposite to the force that we created. If you created the force here, friction always opposite to is. What is the function of friction? To stop the movement of the object. Friction always stop the movement of the object. But there is a limit to friction. Friction cannot be an unlimited value. There is a limit to friction. Right after the limit, it will never be increased. So now think about if you there is a object, you are using 5 Newton. The limit of friction assumed as 30 Newton. If you insert 5 Newton here, friction will be 5 Newton. If you use 15 Newton here, this will be 15 Newtons too. If you use 25, this will be increased to 25. Until now, the object does not move. If you use 30 Newton, it becomes 30 Newton. Until now, the object will not be moved. But if you insert 31 Newton, but the friction cannot be created 31 Newton, so it will be remains as 30 Newton. What is the difference? In this side there is 1 Newton. The object started to move. That is the story of the friction, and the friction is the contact force. And there is a equation for the friction. F equal mu r. It's not in the syllabus, in your syllabus. F means the friction. R, we can say R is not exact weight, we can add this weight, and mu is the surface nature. So you can identify the friction is depends on these 2 points, the weight of the object and the surface nature. And you can see if some object has a high weight, large number of weight, there is a large number of friction. Think about a cupboard or something like big, you cannot move it because there is a high friction, because there is a high weight. And the surface, if the surface is rough, you can hard to move that. That's why we use powder as a lubricant in the carom gear, because we need to very less surface friction, right? We need to smooth that one. If you need to high friction, what happen? If you need to high friction, what you need to know, you can increase the weight of the object, or you can rough the surface, increase the roughness of the surface. If you need to if you need to reduce the friction, you can reduce the weight, right? Or you can smooth the surface. Think about, you need to move a cupboard, you cannot move that cupboard because the force that you created is not enough for moving that, because there is an equal amount of friction. In that case, you need to reduce the weight of the cupboard. Otherwise, you need to make smooth surfaces in the cupboard and the floor. And in the bicycle, there is 2 things. In the axle here, there should be less friction. That's why we apply grease or oil to there. But in the brakes, in here there is a brakes, the brakes should be high friction, otherwise it will not be function. So do not apply grease or oil to the brake pads, because it will decrease the friction. And the pressure. And now there is one thing to tell about the friction, that is, if you use 30 Newton, the friction will never exceed that the force that you inserted. It always equal to your force or less than your force, so it will never become 31. It will be 0 to 30. there's a range. And pressure is the amount of force pushing the certain area. P equal F over A, that is the formula. Pressure equal force over area. So there is a unit, that is Pascal, or you can say Nm mine 2, Nm this mine 2, or like this, right? Now think about here, P equal F over A, right? Now I hope you can generate the unit. This is Newton, this is meter to square, that's why it's here, right? Oh, that's one thing, that is Pascal. In here, if they give you some value, you can substitute here and take the value. You can do some changes, you can change these things, right? Like A equal F over P, it is mathematics, right? Or you can just transfer this one to here, like F equal PA, right? And you can do many things, right? And yes, you can, yes, those things. A equal F over A. Think about here, this is my point. If numerator increase, the numerator shall increase. If denominator is increased, numerator is increased. That is inverse relationship. Denominator has the same relation, but numerator has the inverse relation. Now you can think what happened to the here. Now they have mentioned keep the size of force the same. The force does not change. So what happened to the area? If area increase, pressure should be decreased. Here, for a larger area, pressure will be low. So vice versa, you can say what happens to the small area, pressure will be high. For a small area, pressure will be high. There is an inverse relationship, right? And again, in here, P equal F over A. Now what happened? Area is a fixed. Area does not change. Now we increasing only force. What happened for the last force? Because this is a numerator. If force increase, pressure should be increased. If force decrease, pressure should be decreased. That is the point. And you need to know the formula, and you need to know the units. And if it is some question, you need to substitute the value with the units and calculate it and get the answer. And SI units, you need to read these SI units. That is not much, and you need to unit name and the SI unit. And why do we use SI units? Because we need a standard unit for all of the things. Otherwise, someone says from another unit, another one cannot be. I get understand. If I say some distance from miles, you cannot get idea because you are adapted to the kilometers, right? Like that. As I remember, USA use miles, Canada use kilometers, like that. So in such case there is some differences. That's why we use SI unit, so we can communicate all as in one standard level, right? And we use some prefixes and to easier to use, because if it is large number, right, if it is 5,000 or like here I write 5 million, right, it's easy to use 5k. This is easy to use 5m, right? The m denoted these things, the k denoted these things. Like you can see what are the things here: mega, kilo, deci, centi, milli. You can see mega, giga to up, all are the capital. From here all are the simple. This is mu. You need to know the table and the values. And there is another units, because there is not only the SI units are present, like there is time, there is many things. To length, there is many things. There is something, there is light years, no? Light years. It is take to measure the distance between the two stars, right? And the pressure is this one, or this one can be used. Speed is unit is this one. M is mine 1 or M Yes. And volume is this one, or you can use liters to measure the volume. This is the point, and balance and unbalanced point. In there you need to know the only point that is becomes a balanced force, both should be opposite side and the values should be equal. Otherwise there is unbalance, right? Like tug of war, right? I am writing in here. If it is 25 newtons to this side and 20 newtons to this side, it will not be balanced. The total one is 5 newton to here, right? You need to identify what are those things, right? And here you can see the front force is more than friction, so this is speed enough. So what happened? The both are equal, so there is balance force. So it will not be moved, it will not move. But if it is in the movement, it will continues the movement. Otherwise it will be the same. If it is this side, it is slowing down, and you need to know if it is not a force, right? And if you have already a movement, it will be maintain his movement, right? Otherwise it will not. And you have measuring from the force meters, right? And designing structures. This is the end of the part, and I hope until now all other this part. I hope until now all other complete. Safety standards. Read these things, and there is not much theory in the lesson. And next part is sound.